So, welcome back. Today we have something slightly different. We have to make 10 of these parts. They are made out of aluminum. They have a M12 by 1 fine thread on the end. And they are bored out to 14 millimeters, and then half of the diameter is milled away. And what these are rain covers for sensors. Sensors come in a housing that's threaded on the outside with a 12 by 1 millimeter fine thread, and the sensor in the specific application looks out on the end of a piece of equipment, and rain can drop down and run over the end of the sensor. It's a capacitive sensor, and of course it reacts to the water, and in that application you don't want it. So the person I'm making this for designed this little rain cover that screws onto the end of the sensor like this, and it's like a little roof, so no rain can run over the face of the sensor. So quite a neat little part. We have to make 10 of these. Okay, I already chucked up a bar of 16 millimeter free machining aluminum. And first step, of course, is to face chamfer, spot drill, and drill it to tap size. So let's go. Okay, now we need the tap drill for the 12 by 1 millimeter thread. And in the metric world, this is really easy. You take your tap, you look what the dimension on tap is. This is a 12 millimeter by 1 tap or thread. That means nominal diameter on the outside 12 millimeter, and the pitch, that's distance between the gear, the thread flanks, is 1 millimeter. So you take your nominal diameter of 12 millimeters minus the pitch, that's 1 millimeter. 12 minus 1 is 11, and that's your tap drill. No need to look up in a chart, just it's that simple. Well, that's the tap drill. I will take a small boring bar and machine the 14 millimeter bore in front of the thread. I touch off the end of the bar with the cutting tool. I zero the dial on my bed slide. Then I move in 12 millimeters, and I bring up the stop on my bed slide. Okay. Okay. I also put a small chamfer on the outside of the bore, just with a three-sided scraper. And I made a slight chamfer on the inside of the bore where the tap starts, where the thread. We take our tap. I'm not going to tap these by machine power because it's only a few turns, yes. I'm just tapping this by hand. Oh, there we go. Now we can go to the milling machine. But before I go to the milling machine, I will do exactly the same on the other end of the bar, so I can make two at a time. Due to the magics of television, flip it around and we have the same on this side already. So we can now go to the milling machine and make the cutout, and then we'll go back to the lathe and part them off. Okay, this is set up on a milling machine. Get this out of the way. I have my collet block with a 16mm ER25 collet directly clamped to the table and aligned. Normally I would clamp it in the vise, but when I did a setup I didn't have a vise on the machine's table, so I clamped it directly to the table. Now we can come in from behind and set up our part. Just move it out so it sticks out about this far, and tighten down the collet block. I set the depth stop so I can just come down and lock the quilt, and then I have the right depth. Now I'm going to touch off the end with the cutter. And zero out the DRO. I already touched off on the first part I made on the outside of the diameter, so I have my offset there too, and now it's just milling by numbers. There we go. First one done. Now we can take out the bar. If we can get it out of the collet. Flip it around. And to the other side. I'm not using a work stop because the ER25 collets I'm using in this block they move the part axially when you tighten them down. So let's do the second one. Get down. And second side done. Let's take it out. Okay, we made the cutout on this side, and on the other side. And now we can go back to the lathe and part it up to off to the desired length. That's of course not right. Before we part them off of the bar, I'm going to deburr them, because I still have something out to hold on. And I'm just using a Noga tool with the narrow blade to get a nice small chamfer on these edges. And then we break the ends, the edges here very lightly with a needle file. Just so nobody cuts his finger open, and just dust it off with some fine Scotch-Brite. That's just a nice last finishing touch. For parting off, I'm going to use my high-speed steel parting tool, and I ground the front edge of the tool to a slight angle so the right side is leading edge, and I do this so I don't get as much burr from parting off. This is my absolutely preferred parting tool. This is just a Churchill Empire. These have just a T-shape, so the lower body of the blade is relieved and the upper side is cutting, and you only grind the front, you only grind the front of these sharp and you leave the top untouched. Don't grind the top of these or they won't work anymore, because when you grind in a chip breaker or something like that, the lower side of the chip breaker gets narrower because the upper section of the blade is slightly tapered, and then it tends to rub and seize in the cut, and yeah, horrible things will happen. So don't grind the top of these. They work absolutely well with 0-degree top rake, even in aluminum. And as these are high-speed steel cobalt 12%, they are super tough and they last a long time. And I don't use my inserted parting tool very much anymore, since I use these Empire blades or Churchill blades. Let's line up the edge of the blade with the front of the part, zero the bed slide, move in 15 millimeters. So we're going to part this off to final dimension. And I don't want the part to be flung around when it's parted off, so I have a drill and a drill chuck to catch the part. There we go. One part done. Now we can take the bar, flip it around and part off the other side. Or the other end. And by the way, I don't like to work with aluminum very much, as it gets cleaned up so easy. People say it's easy to work with aluminum, yeah, but it's also super easy to mess it up, and also it tends to seize on the tool. builds up an edge on the cutting tool. It's soft, and yeah, steel is way nicer material. A good quality steel is always nice to work with than this soft aluminum crap. Even the 70-75 aluminum is like cheese. There we go. Now we can take these two parts, and the parting tool still leaves a bit of burr on the backside because we're parting off into a thread, and we're just going to take a stone and lap the backside flat and clean. Okay, I machined all 10 of the sensor covers or rain covers, and when I part them off they have this burr on the end, which needs to be removed, and I could check it up in the lathe again and take a facing cut, but these parts are quite fragile and I would have to make an arbor and where I can screw them on and take a facing cut, and I'm just not willing to do that. Not for this purpose. We'll remove this burr by hand. We'll just clamp it up in my small vise. Take a file, and work down this. It's quite a heavy burr from parting. As I said, when you part off into a thread, one of these threads gets a bit pulled out and ends up as quite a solid burr. But with some filing, you can remove the spur without a problem. And if you're careful, you don't run over the edges and round them over. The file I'm using is quite coarse, but I'm finishing them off on a coarse aluminum oxide stone anyway. Emery cloth on a glass plate or on a steel plate would work just as well, but I had the stone in arm's reach, so I used it. Now forget the oil. If you use a stone for oil, a stone for aluminum, use some light oil to prevent it from pinning with aluminum. And now we have, of course, a sharp edge where the thread exits the part, and we take again our no-go, just so you don't cut your finger open when you handle these. So there are 9, and there's the last one, and we will do the same to this one. Okay, I cleaned up the part. I washed all the excess oil and the grit from the Scotch-Brite and so on off. I ran a tap through the threads, so I'm sure that they are clean and there is no burr preventing them to be screwed on, and I think they're done. I will pack them up and send them out tomorrow. So that was a nice little project, small production run. It's not something I'm doing in my own shop every day. Normally I make one-offs or 2 of something, not a small run with 10 or more. That's a bit uncommon for me. So interesting part. Hope you enjoyed. Thank you for watching and see you next time.